Donc, merci beaucoup. On est très content d'être là. Et puis, peut-être, Pascal, tu peux rappeler le programme
Oui,
et présenter
voilà. Alors, moi,
l'interprétation.
j'ai besoin enfin, voilà. À mon âge, j'ai besoin de, 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 de transmettre. Alors, bon, déjà, je vais peut-être remercier déjà, évidemment, toute l'équipe IDEE qui est venue là. On sait combien c'est important, hein. Le but de l'IDEE, c'est de. Il y a une ambition qui est à la base de ce projet IDEE, c'est de développer une recherche en éducation qui soit plus ample, plus rigoureuse, plus ambitieuse, et qui devrait normalement profiter à toute la communauté de recherche, au moins française. Alors, le LARAC a la chance de faire partie de ce projet IDEE, et évidemment, au-delà du LARAC, toute l'UGA. Et pour rebondir sur la formation qui va être proposée ce soir, la, enfin, j'insiste un petit peu là-dessus, parce que on est vraiment sur des présentations techniques qui sont assez mal connues finalement de nos communautés sur l'éducation ou psycho, et qui, je crois, vraiment ouvrent des horizons pour faire des choses de dimension plus large et probablement aussi mieux adaptées méthodologiquement, etc. Donc, je fais un peu de la pub pour la formation qui va être faite ce soir, parce que je pense que tout le monde pourra en profiter. Je vois des doctorants, comme les anciens doctorants ici, c'est extrêmement important. Je voudrais aussi commencer par remercier les personnes du LARAC qui ont organisé. Nicolas, merci beaucoup.
De rien.
Il fait un gros travail. Alors évidemment, il y a toujours Sandrine, c'est la gestionnaire du labo, qui n'est pas présente, mais qui est toujours présente pour présenter cette chose-là. Merci à Michaela, merci à Laurent, voilà, et à Pascal pour la direction du laboratoire, d'avoir accepté cela. Alors, donc, ce matin, on va avoir des présentations. La première va être faite par Samuel Falcòn Pulido, qui est de l'université Gran Canaria, de Palmas, un endroit qui fait un peu rêver. Voilà. Et il se trouve que on a découvert que ils sont extrêmement forts et à la pointe de techniques d'investigation, notamment via l'utilisation de l'intelligence artificielle dans des traitements de données, d'observation, audio surtout, mais aussi des traitements de données de questions ouvertes. Donc Samuel va nous présenter son travail. Sachez qu'il est actuellement en situation de doctorant, hein. Il est doctorant, il n'a pas encore soutenu sa thèse, mais il a déjà un éventail de travaux assez impressionnant. Ensuite, c'est Laurent qui nous présentera donc le travail qui a été réalisé sur les observations de classe. Bon, voilà, Laurent, c'est pas la peine que je le présente, voilà, des conférences au LARAC. Alors, après quoi, on aura un buffet. Et puis, à partir de 13h15, je ne vais pas me tromper, 13h15, il y aura donc une démonstration du Teaching Lab qui est, alors, l'équipe que dirige Philippe dessus, Domenico Freda, laquelle est associée Fiorella, qui est là-bas, voilà, ont développé un système d'analyse automatisée de ce qui peut se dérouler dans des sessions de formation avec du matériel très sophistiqué. Moi, je n'y connais pas grand-chose, je ne peux pas développer toutes ces choses-là. Et donc, il y aura un groupe d'une vingtaine de personnes qui pourront aller visiter. Alors, évidemment, pour les questions de classe, on ne peut pas y amener tout le monde, mais la session de présentation sera filmée et sera retransmise. Puis elle sera analysée via tout le matériel performant du Teaching Lab pour qu'on puisse faire une démonstration vers 15 heures, 15 heures à peu près, enfin, un peu de temps après, des possibilités d'exploitation du Teaching Lab. Bref, c'est assez, c'est assez bluffant. Moi, j'ai été assez impressionné par ça. Alors, il y aura du coup un temps de latence à un moment donné. Donc, ce qu'on vous propose, c'est qu'on fasse une séance de démonstration, d'observation de classe, d'engagement des élèves. Alors, dans un format moins technologique, oui, mais qui montre qu'on peut faire à partir de grilles assez simples des codages d'observation qui se révèlent finalement assez pertinents et assez opérationnels. Voilà. Et donc, ensuite, de 15h45 à 17h30, il y aura la formation assurée par et voilà, je peut-être déjà trop parlé, j'espère n'avoir rien oublié. Voilà. Donc, merci en tout cas de votre présence. Il y a aussi des gens qui sont en ligne.
Bonjour, vous m'écoutez?
Oui.
D'accord, parfait. Bon, merci Pascal pour la présentation. Je suis Samuel Falcòn de l'Université de Las Palmas de Gran Canaria. Euh, je vais faire ça. Est-ce que vous voyez
Oui, parfaitement.
ma présentation?
Oui.
D'accord, parfait. Et bon, moi je parle un peu de français, mais aujourd'hui je vais faire la présentation en anglais car je suis pas, le français c'est pas mon fort. Et alors, bon, je vais commencer hmm, à parler en anglais. Well, as Pascal said, my research focus on obtain observations of verbal behaviors of teachers in secondary education and to see how these verbal behaviors impact on students' outcomes. And for this, we gather information through audio recorded lessons. This procedure, of course, of obtaining qualitative data and coding it, etc., it can be really time-consuming. So to enhance the efficiency of the process, we have developed and integrated different methods for extracting key information from the audio recordings. And this is the first thing that I'm going to present today, these methods. And we have another line of research for investigating the use of large language models like ChatGPT or many other models for automatically coding answers to open-ended questions. Of course, open-ended questions are also a source of qualitative information. So we are implementing these methods to improve the efficiency and save time and money, basically. So before I start, again, I would like to thank Pascal Bressou and everybody from the LARAC for the invitation. And yeah, also you can interrupt me if you want, but I think there will be a time at the end of the presentation for questions. But if you want to interrupt me, that's nice. Just raise your hand and I will be happy to answer. Well, that's it.
We have
Yes.
a question. Is your PowerPoint already? Did you change your slide during the presentation? Actually?
No, not yet.
Okay, so that's not a bug. Okay.
Okay. Well, this is the outline we're going to follow in the presentation. I'll start by giving just a bit of context about the framework in which we work in the University of Las Palmas. Then I will talk about the data collection, the data processing, the data analysis, how you can use apply this methodology to other type of verbal behaviors, and also the bonus track about the automatic coding of answers to open-ended questions using large language models. So that said, let's start with a bit of context. As I said, our line of research focuses on teachers' verbal behaviors, and specifically on teachers engaging messages. These messages are those explicitly addressed to students with the purpose of engaging them in different school tasks, for example, studying, do their homeworks, etc. And these messages have two dimensions based on how the teacher frames the messages and what kind of motivation the teacher appeals to. Let me explain this a bit better. So in the frame dimension, which is based in the message framing theory from Rothman and Salovey, we can identify two categories of messages: the game frame messages, which are those that emphasize the benefits of engaging in a task. If you do this, you will get this, for example. And the loss frame messages, which are the opposite. They focus on the disadvantages of not engaging in a task. If you don't study, you won't get the, I don't know, the bicycle, for example, not the bike. Then this is the first dimension, and we have the other dimension, the appeal dimension, which is based on the self-determination theory from Deci and Ryan. And this dimension informs us about the types of motivation that a teacher can appeal to when trying to involve their students in school tasks. For example, they can appeal to extrinsic motivations like rewards or punishments, introjected motivations to the feelings, basically, or to more internal motivations like the identified motivation, like if you study now, you will get a better work in the future, and the intrinsic motivation, engaging for the pleasure of the activity itself. So this, integrating these two dimensions, we end up with 8 categories of engaging messages. And well, some of you may be wondering why we are focused on the study of these messages in particular. And this is because they have, they have shown some interesting results concerning both students and teachers. So for teachers, we have seen that the autonomy the teachers perceive in their school influence their use of engaging messages, and we can identify different profiles of teachers. For example, those that only use game frame messages, those that use all type of messages, the 8 types of messages, teachers that don't use any type of message at all. They just go to the lesson, they teach whatever they are teaching, and that's it. They don't try to engage students. And also, we have seen that the type of message delivered to students has different influences on their performance, well-being, and motivation to learn. For example, it's not the same using game frame messages that appeal to internal motivations that using loss frame messages that appeal to extrinsic motivations. So this is what we have found so far, and that's why we are focusing on them. But there's a problem, that these previous results that I've just shown are they measure the engaging messages only through a student self-report. So the students are reporting about the perception of the messages the teacher used, but we didn't have the real observations of the messages. So to close this gap, we set out to obtain direct observations through audio recorded lessons. That's why we are working with audio recordings. Of course, this, as I said before, can be really time consuming and very costly, because you need to code all this information in order to extract the observations. So for this, we developed and implemented different tools to optimize the process. In order to make the seminar a bit more interactive, I added these slides at the end of each section if you want to ask me anything, but if not, it's I will continue and you can ask me at the end. So any questions so far? I guess no, because it was just a bit of context, but okay. So let me continue. Now, let's move on to the next section, okay, where I will tell you about the procedure we follow to collect the data. Just for you to know, most of the information that I'm going to give you from now on can be found in these two papers. I will give the slides to Pascal at the end of the presentation, in case you want to see them again or whatever. So you will have this, okay? Okay, so in a controlled environment, as you know, behaviors can be influenced or altered by the awareness of being observed. So, well, I put an asterisk here because I'm going to talk about this a bit later. And for that reason, our research has always focused on studying teachers' behaviors in their usual working environment, such as the classroom, of course, so that we can get a truer picture of how they communicate with the students. So we always put the focus in the naturalistic settings, okay? Okay, so now, how's the procedure? At the beginning of each academic year, we contact the schools, the principals, the management teams, the teachers, and we explain to them the objectives of our research and what they have to do in order to participate, record their lessons, etc. Specifically, we ask them to audio record their lessons, the last 8 lessons of the term. In Spain, we have 3 terms, so from grade 8 to 12 to the high school. That's our conditions. Of course, with each participant, we sign a consent form where they allow us to record their voices, and we commit ourselves not to disseminate, complying with that Data Protection Act. And I've put here another asterisk because I'm going to talk about something about this a bit later. Okay, so how do we audio record the lessons in a naturalistic settings? We ask the teachers to use one of the following 2 devices, okay? So they can use either a small recording, which is here, just right here, okay? That it's a small recorder that can be placed with a clip near your mouth. And of course, we teach them how to use them, but they are really simple. Or alternatively, we ask them to use their cell phones, okay? And for this, we provide them with this necklace, you can see here, so that they can hang their cell phones near their mouth, okay? So they record the lessons, the 8 lessons, the last 8 lessons of the term, and then we ask them to send us the audio files. Okay, so when we start, we ask them to send us the audios via a OneDrive link. They just need to connect the device into the computer or with their phones and upload the audio files. But nowadays we have developed a cross-platform application which can be used in the computer or in the phone, so that they can send us the data more easily and consult other data of their participations. So some considerations, okay, about the asterisk. The first one, do teachers change their behaviors knowing that they are being recorded? Because this is one of the most asked questions that we get. And well, the answer is no. Maybe in the first 5 minutes of the first lesson, but they don't really change their behavior. Okay, believe me, we have heard all sorts of things. Okay, we have heard everything. And the second asterisk, which is also they usually ask about this. Do we only record the teacher's voices or also the students' voices? So on rare occasions, for example, when the teacher is giving feedback to a specific student or all students are talking, you can hear their voices. But most of the time, only the teacher's the teacher's voice is being recorded because the recorder or the phone are placed near their mouth. Okay, so other considerations about the data collection procedure. If you want to do this kind of studies in naturalistic settings and audio recording the lessons, there are some small things that are really obvious, but you will need to take you should always keep in mind. Okay, the first one is that the simpler the procedure for the teachers, the better for us, the researchers. Okay, we should try to make all tasks as easy as possible for them. This includes, for example, if they are not able to upload or send us the audio files, we need to move to the school to collect the audio files and, well, whatever they need. This is really important because for them to be engaged in the research. And the second one is that the audio quality is the key. Okay, this is the primary source of data. So you will need to check the devices before, or maybe ask them to do a small test with either the recording or their cell phones, just to check if the audio quality is good enough. Because if not, you will probably need to discard the information from that teacher, and that's a pity. So that was pretty much all about the data collection. Any questions so far? No, doesn't seem so. Okay. So let's move on now to the data processing. Okay. Now we have the data, we have collected the data. How do we process it to obtain the observations of the teachers engaging messages? So there are different approximations. If we delve into the literature, into teachers' verbal behaviors in general, not only engaging messages, there are different techniques for obtaining observations, okay, from the audio recordings. For example, some researchers, you will see in the literature, that they listen to the audios directly, but this, as I said before, can be quite hardworking and time-consuming. Okay, it really depends on the, let's say, on the amount of data that you have. If you are going to analyze, I don't know, maybe 3 lessons, it's okay to listen to. But if you are going to analyze 8 lessons per term, and you have, for example, 50 participants, that's a lot of, that's way too much hours of audios to listen. So in our case, that was not possible. There's another approach, which is also quite common when you are working with bigger samples or with bigger amounts of data, which is transforming the audio files into text with a transcription service, and then analyze the transcripts. So this, while it's true that this can cause a bit of, well, the loss of information, and I've put here an asterisk because I'm going to talk about this in the next slide. The reality is that the identification process, the coding process, is less costly, less time consuming, and, well, it's like a balance. You lose a bit of information, but you can analyze more data. So we decide to follow this procedure, the one about transcribing the audio files. Maybe some of you, if you are interested in this, you can think or you can ask yourself how to transcribe the audio files. And there's a lot of ways to do it. For example, you can use the software as service, which allows you to connect and use cloud-based apps. These are the solutions of Microsoft, Google, Amazon, whatever. They are really easy to use because they have an interface for the user, and the quality is really good of the transcription, but you will need to send audio data, which is confidential, to third parties, and it also costs money, of course, not that much, but it's not free because we are using a service. There's another option, which is using open source software, where you download the speech-to-text model and you run it locally in your PC. So here, the king of the kings, it's Whisper from OpenAI, the same company that owns ChatGPT, but this model is open source. You can download it. The quality is really good. The data stays in your PC. You're not sending personal data into other companies. It's free to use, but it can be a bit difficult to install if you don't have like technical knowledge. And that's why I recommend you, if you want to use this kind of open source models, to have a technician or a software engineer in your team. And it also requires a powerful PC. How powerful? You can run them for example, in a gaming PC. Okay, if you buy a gaming PC, you can run them. I hope you can hear this example. So
I think we have a question.
okay.
Je voulais juste annoncer pour les gens qui sont là que OpenAI, on a une instance à l'UGA qui tourne en ligne sur les serveurs de l'université. Donc, ce qui vient d'être dit, on avait besoin d'un gros ordinateur pour le faire tourner. On a réglé ce problème. Il s'appelle Tadam. Il a été développé par un ingénieur de la MSH, de projet d'eau, et voilà. Et donc, on a, pour tous les personnels de l'UGA, accès à cet outil de retranscription automatique gratuitement sur des serveurs sécurisés et avec des puissances de calcul importantes.
D'accord, ça c'est parfait. Ça c'est une autre solution. Alors,
Alléluia.
ouais. Okay, so let me just tell me if you hear this.
Yes.
So this was an example of Whisper, okay? The one we are using it, but of course you can use your own models. It's okay too. But just to show you the quality of the model, okay? So I think I'm going to put it again. Here you can see the transcript, and just listen to it again. So well, as I said, this is only an example, but as you can see, the audio quality is not the best because of the noise of the chairs and everything, but the model still perform well in transcribing the teacher's voice. So I just wanted to show you an example of Whisper. Okay. So this is how we transform the audios of the lessons into text. And now what? No, okay. After transcribing tens or hundreds of hours of audios, we can end up with thousands of pages of text. So we end up with the same problem that we had before, like a lot of information to analyze. Reading through all the transcript, of course, is not possible. It's really slow and can lead to decision fatigue. No, if you're searching for the engaging messages and you have been reading transcript for like 5 hours or 6 hours, you are going to start missing engaging messages. So it's not a good method. For this reason, over the last few years, we have developed 2 methods for extracting the information about the verbal behavior, the engaging messages, which I'm going to present you. Okay. So first, the method A. The method A is based in filtering and lexical rules. Okay, it's nothing like super new. Okay, this method is easy to follow, it's easy to use, it's free, but it may not be the fastest to extract the information. Of course, it's an improvement, but it's not the fastest. And then we have method B, which involves using large language models, so using artificial intelligence. And this method is faster and it's state of the art, but it's still experimental and it's pretty technical. So you will probably, again, need an IT guy or expert to use it. So first, I'm going to explain the method A to extract the information of the engaging messages or whatever verbal behavior from the transcript. So let's say you want to gather observations. You have audio recorded the lessons, you have transcribed them, and now you want to extract the information from the transcript. But you don't have real examples of these verbal behaviors, okay? You don't know, you don't have real examples. So in this case, you can follow these steps. First, you can use the theory or a scale that was used to measure that behavior or whatever, to create a list of words, of keywords, that you think they will be present in the messages or around the messages, okay? So first you create a list of words that are going to be, in the messages or near them. Then you filter all the thousands of pages of text with these words, okay? To obtain only the sentences of the transcripts that contain those words. And lastly, you code these filtered transcripts containing only an 80% less, so containing only a 20% of the original information. And in this way, you can save time and resources. So, for example, if you have a transcript with 1,000 pages, okay, you can say, okay, I'm going to create a list of words like study, work, future, I don't know, grades, achievement, whatever, because I think those words are going to be around or in the messages. And now I'm going to filter all those pages of text to get only the sentences that contains those words. So you filter them, and then you end up with only, if you had 1,000, then you will end up with 200 pages of text to manually code it. So that's an improvement. Okay, you don't have to go through through the 1,000 pages. You only go through the 200, and well, that's you will save time and resources. Okay, that's a method. Of course, there is a risk because you may miss some messages that are not related to those words that you extract from the theory or from the scale. But again, this is like a balance. If you have a lot of information to analyze, you can do it very slowly, but you can go through all the information, or you can do it faster and sacrifice a bit of information. So this is the first scenario. But there's another scenario with the method A, which is the one where you already have real examples. You already know which type of messages do teachers use to engage students, and not only from the theory, but you have like real examples, because often the reality is not exactly the same from as the theory. Okay, so in this case, you are going to use the real examples that you have to create, again, a list of words that are very common in the messages, but less common in the rest of the text. Okay, again, words like study, achievement, but for example, I don't know, maybe a word that is related with those messages, but you didn't think of at the beginning, or the theory doesn't, no, you didn't think about it, is, for example, parents, because when teachers try to engage the student, they usually do it by appealing to how their parents are going to feel. I don't know, okay, I'm just giving an example. So with these real examples, you can optimize a lot this filtering method. And you do again the second step of filtering the original transcript to obtain only the sentences containing those words. And based in our experience, doing it in this way with real examples, okay, creating the list of words with real examples, you can end up with a 90% less of the information, keeping not only the same messages that you found using the previous method, but even more, because as I said, maybe in the theory, or you think of a list of keywords, but there's some words that are not present in the theory, but they are present in the reality, okay? So this method is better. This is method A. Really simple. You just filter the information with a list of keywords, and you end up with the sentences containing that words. Now, method B. This method can only be used, or we recommend to use, with real examples, okay? Because it works better. So in this case, what we are going to do is to create a dataset with all your real examples and train a large language model with those real examples, okay? For example, you can train a GPT model. But not only, you are not going to train it only with positive examples of engaging message, but also with negative examples of sentences that are not engaging messages. Then you ask the model to read through all the pages and to extract only the sentences that are similar to the positive example, to the engaging messages. And in this way, we can end up with a filtered transcript containing 90% less of the information, and well, having really good results in terms of agreement between the GPT and the humans. So yes, this method is really useful, but as I said before, it's a bit more technical, and well, of course, it's state of the art, so it can be improved. So these were the methods. Okay, now we have transformed the original audio recorded lessons into text, and with those methods, we were able to identify the engaging messages. So now we have the observations. for example, no, we know that teacher A in lesson 1 said, I don't know, 5 messages or 10 messages, okay? So now we have the observations. But is that all? No. Why? Because we can still extract more information. I don't know if you remember asterisk 3 about losing information when transforming the audio files into text, which is true, but we can, now that we have the engaging messages identified with the timestamps of the transcripts, we can go to the audio file and then extract audio clips for each message. So now we have both the text of the message and also an audio clip of the voice of the teacher saying that message. So we don't lose that much information, okay? Because with this audio information, we can still do more analysis, which is what I'm going to talk about in the next section. Of course, these methods, method A and method B, are not without limitations. Both of them are faster than listening to the whole audio lessons or reading through all the transcripts. But of course, as I said before, we may miss some information. But again, this is like a balance. If you have huge amounts of data, you can do it very slowly, going through all your data, or use this type of methods and, well, assume a loss of information, but being able to analyze more rapidly and okay. So any question about the methods? I know that okay, so there's a question there. Okay. I don't listen to you. If you can.
Yeah,
okay.
Can you hear me?
Yeah.
Okay, so I have some questions.
Okay.
About your usage of LLM. So LLM are big models. So that's why OpenAI stole so many texts they do not have the right to use to make GPT. And for sure the same for Google. Do you have enough text to ensure that your model does not overfit on your data? So the advantage of LLM is that it could be generalized different situation and analyze different situation. But if you overfit you with your LLMs, there is no longer any benefit of such big models. So you can use, let's say, standard LLM, language model.
Okay, so that's a really good question. And what we have done to analyze this is, of course, we have done different tests with different, let's say, different amounts of examples, okay, and different proportions of positive examples and negative examples. And after conducting all these tests, we end up with a combination of and a proportion of positive examples and negative examples that gave us a fine-tuned model, which after analyzing the whole transcripts gave the same or almost the same results as the ones obtained through manual coding of the transcripts. That's something that I didn't mention before, but of course, to test all these methods, both method A and method B, we perform different, we perform manually coding of the transcript. Of course, not all the transcript, but we took as a percentage, I don't remember if 20% of the sample or 30% of the sample, we manually coded, okay, between two humans, okay, those are the engaging messages, and now we are going to see if with those methods we obtain the same results or better results or worse results. So yes, we did a lot of tests, and about the problem of overfitting, I would say that if you are going to use this method in particular, the one about fine-tuning or training an LLM to extract the information, I would say that you should conduct your own test, because what has worked for us in our context may not work for your verbal behavior, because, I don't know, because we are studying feedback, for example, and teachers are constantly giving feedback. I don't know, okay, it's just an example. So in this case, the proportions of real examples and, well, of positive examples and negative examples are going to be different from the one that we found to be good enough. So I don't know if I answered your question, because it was a bit technical.
Yeah, mostly. So my main worry is so to check for the overfits, you can check that while you train your model. And there are rules to check the losses when you train your model, to check if your model is overfitting on your data. And the main point with overfitting is that the model will, so the bad thing is not the false positive, so false message you are searching for, because you are filtering them at the end. The bad thing is the false negative, so missed message. Okay. So yeah, this is the drawback of this method. If your model is too overfit of your examples, you won't generalize on similar sentences and similar contexts, and you will miss some examples. So as you said, it's a trade-off between time and accuracy.
Yeah, exactly. That's totally true, and that's why I repeat it a lot of times, because I know that this is, of course, it's not the perfect solution, but it's just a solution. And if you're going to use it, you should know that you are going to, of course, miss some information. But if you think about it, even if you manually code all the transcript, or if you listen to all the audio files, you are also going to do some mistakes because of decision fatigue. As I said before, if you are reading thousands of pages of text per day for 6, 7, 8 hours, you are going to miss some engaging messages. So yeah, it's not perfect, and the overfitting problem is something you should keep in mind when training these models. Of course, always do test and calculate the agreement between humans and the machine. But if you have good enough results, I mean, between humans and the machine, you can conclude that, well, it's a good method for studying that verbal behavior in that situation. So, more questions about this?
I have another question.
Yes.
No, but in a way to follow up on this. So I'm not sure speed is exactly, in fact, the right notion you want to emphasize, because so you have a trade-off between. I think behind speed, the interesting notion is the amount of data that you can generate.
Yeah.
So this is why speed is interesting. I mean, a computer who does it, right? So you can go on a holiday and you get back, you have the data. So speed as such is not really what you want. What you want is to have a lot of data. And there's a trade-off between having a small amount of very precise information. If you want to estimate some average of, I don't know how many per hour of that type of message is sent, versus having a very large data with more noisy information. But at the end of the day, if you have a larger data, you can compensate noise with sample size and have you have a consistent estimator of some frequency of the messages. And I think that's really the way you want to think about it, right? Speed is providing a lot of data, and then you're happy with having more noisy data, because at the end of the day, the precision of what you get is better than a very precise estimator with very precise measurement with very few data. But you can go with that, right? In a way, with your comparison, you can you can tell us, given the ratio of precision, how much more data I need to have for this approach to be relevant. And maybe the more data you have, the less imprecise you can afford.
Yeah, totally. When I thought a lot about the speed, but of course thinking about analyzing huge amount of information, and that's the strong point of this type of methods. It also depends on the objective of your research. If you want to perform advanced statistical analysis to do inferences, you will need more information. And if you want more information, you will need to do or use this type of methods to just optimize the process, because if you don't use them, you can spend 1 year coding the data of the previous year, you know. So, and if your objective is just to perform a descriptive analysis or a qualitative analysis, of course, you don't need to use these methods, because you can use them too, but maybe if you want a more precise analysis with where you analyze the content of the message or whatever, you can manually code the transcripts or the audio lessons. It really depends, but yes, I also think that that's the strong point of the method. So, if another question at the end, yes.
So I have a question about confirmation bias, because the other methods that you mentioned, you define categories beforehand, right? So
I listen to you.
Can you speak louder?
Yes, please.
So I've got, I believe I can say much louder, right? It's a question about confirmation bias. So because in all the methods that you mentioned, you have categories beforehand that you define, right? So it's based on the theory, it's based on the cultural background, and etc. And so the model is going to be basically looking for what you told it to look for. So I'm just wondering if, like, is this worse than you like including? Like, do you have some tips on how to avoid this? Because I'm just thinking, you know, it will basically find all the typical behavior and it will list the atypical behavior as a function of what you defined at the beginning. So, like in this case, for your research question here, it might not be a problem, but like say you're interested in differences as a function of the background of the teacher or the background of the kids, the pupils, you will basically miss the behavior that is maybe the most interesting, like atypical.
I don't listen. I can listen to you because you are maybe too far, and you know, maybe if you can approach a bit to ask the question, because the microphone, I think it's near the.
Je suis pas sûr d'avoir qu'on ait la fin de la question du coup.
Tell me if it's not what you. The question is apparently what about, because you define the real examples on human classifications, right? And what is how is it? There is a risk of confirmation bias because you based your model, you train your model on human classified real examples. That's why. But that's how I understood. But
yes, I mean, it looks like, yeah.
That's what I understood, but because you're so far off the microphone, sometimes your voice didn't reach the computer. So okay, yes, of course, as I said before, there's a risk in using this type of models. The confirmation bias is one of them, but what we have seen, of course. I didn't mention it here because I just wanted to show you the methods, okay? But in the study where we analyzed the let's say yeah, how the precision and everything, all these metrics of the model. We conduct a study, and we did, after training the model and after analyzing the agreement between humans and whatever, we also performed different tests in new information. And what we saw is that the model was able, even if we train it with specific examples, the model was able to generalize, okay, to generalize, and with new information and new teachers that don't use the same type of messages. I mean, they are engaging messages, but they are not set in the same way. For example, if we know that guy, Francisco, okay, that he's very a very serious person, and okay, very strict person, and his type of messages are really different to the ones used by, I don't know, Maria, for example, which is very joyful person, and she does okay, two different type of persons. We train the model using positive examples of different type of teachers. Okay, so these strict teachers, joyful teachers, teachers that use engaging messages in a certain way that are different from other teachers. And in doing so, when we analyze new information, again, we took, in the next academic year, we took a 20% of the transcript, we manually coded, and we found humans, I mean, I don't know, 300 messages. After running the model and filtering all the transcripts with those, filtering all these new transcripts, we found that maybe it was able to find a 90% or a 95% of the 300 messages that the humans found. So of course there's an error here, but based on our results, it's not a huge error. Okay, so the model was able to generalize, and when analyzing new teachers that are different from that, or that use different messages from the ones that we trained it, he was able, yes, to extract correctly the engaging messages. I don't know if I answered you the question. Was that the question or not?
The question, but just to follow up, we know that these models, they pick up also on the salient features, right? They pick up on what's salient, so it's likely that they will pick up on things that are more typical. So I think it's still, it's still a bit like circular. I mean, it will basically probably be pretty good at finding the obvious case examples, and then it will miss, like what I'm trying to say is that it will not miss, like the noise will not be random. There will be a pattern in the things that it misses, and that's a bit of a worry for some students, I guess. Maybe not yours here, but like some students.
Again, it really depends on what verbal behavior you are studying. Now we are studying empathetic messages, and we are also finding good results. Okay, comparing, of course, humans and these methods. So at the end of the day, the reality is that we are finding good results. So of course, this is state of the art, still experimental, and that's why I'm presenting them, because I want more people to use them and to see if they are reliable in different type of verbal behaviors. But in this case, in the case of specific messages that are addressed to students to engage them or whatever, they perform really good. So I think I'm going to move forward because I still have like 10 slides or 15 slides. And then we can talk about this later, or you can also write me via email, you and the other persons, because yes, I don't want you to stay here for 2 hours. So now the data analysis.
Constraints mainly for the
Can you repeat it because you was muted at the beginning?
Yeah. Il faut que tu recommences parce que tu étais mute au début.
We have some time constraints.
Exactly. Yeah, that's right.
So maybe now you can wrap up things.
Okay. Yes.
Go to kind of conclusion. Sorry, maybe for frustrating you.
Yes, of course. I'm going to be quick. So about how to analyze this data, as I said before, you can do a qualitative analysis because you have the observations of the messages. So you can do, for example, a content analysis, a comparative analysis. Well, a lot of there's a lot of types of qualitative analysis, but you already have the observations, so you can analyze them. For example, developing new theories or modify the existing theories based on this empirical evidence. No? For example, you may find a new category of engaging messages that are focused only in achievement, like very, very, very focused on achievement, whatever. It's just an example. And you can do a quantitative analysis. But for doing it, you should standardize your data because not all teachers speak the same amount of words in a lesson, no? So, well, a way to standardize the data is not the only way, okay? Is, for example, by dividing the number of messages said by a teacher between the number of words spoken in the whole lesson. The number of words is usually in tens of thousands, so we also multiply it by 10,000 to get like more interpretable results. In this case, teacher A, okay, so both teachers said 5 messages, or we detect 5 messages, but teacher B use more messages per 10,000 words than teacher A. So that was all. And how to analyze this data, because if we plot the data, we will see something peculiar. Okay, this is the data of the number of messages detected of a particular category. Okay. And we can see 2 things. First, that there are many teachers that don't use this type in particular of messages with their students. As I said before, there are different profiles of teachers. Some of them use all type of messages. Some of them only use a certain type of message. So there are many teachers that don't use this specific type of message. And there's some other teachers that use them into a different extent. No? For example, teacher A use them just a bit, teacher B use them a lot, whatever. So this distribution is called the zero-inflated distribution. It's not, it's not specific from this scenario. You can also see these kind of distributions, for example, while studying suicide ideation in the last 12 months. So in your population, you will have a lot of people that don't think about suicide, and another part of the population that will think of suicide and into a different extent. For example, 1 month, 2 months, 12 months, etc. And how can we analyze this zero inflated data? With harder models, if you have counted data, or with two-part models, if you have continuous data. But they are more or less the same analysis. From your original dataset, you create two datasets. The first one is dichotomous, just showing the absence or the presence of the phenomenon. In our case, is yes, this teacher has used at least one message or not, or he hasn't used any message. And a second dataset without the zeros and only with the observations of the phenomenon. So it's like you put the dataset here. With the first dataset, you can perform a logistic regression, and with the second one, a linear regression. For example, if we were interested in studying the influence of enthusiasm in the use of engaging message, with the first dataset and with the logistic regression, we can answer the question about how teachers' enthusiasm influence the likelihood of using engaging messages. And with the second dataset, we can ask the question, among teachers who do use messages, how do enthusiasts influence their use? So this is a way. It's not the only way. It's just a type of analysis. And if you remember, we have the audio clips of each message, and we can also extract different type of informations like paralinguistic informations such as speech, rhythm, pauses, etc. And there are different models to obtain quantitative information of this paralinguistic data, both open source and commercials. So, well, you have the slides. So I put here all the reference, so you can check it later. And lastly, about the applicability of these methods and other possibilities with AI, you can apply these methods, as I've been saying, into many different types of verbal behaviors. For example, motivational messages, praise, I don't know, fear appeals, threats. There are many verbal behaviors that teachers use in their lessons that can be analyzed using this type of methodologies, okay, to obtain huge amounts of data. Feedback, autonomy supportive messages, etc., etc. Just make sure that the phenomenon you want to analyze, this verbal behavior, can be operationalized, okay? Because, for example, if you are going to study how much time the teacher spent talking to boys and how much time he spent talking to girls, this can be a bit difficult to analyze just from, you will need, for example, a video recording. No, it's not that easy, just using the audio recordings. And just a small bonus track, which is what I'm doing right now with the LARAC, with Pascal and Fernando, is the use of LLMs like ChatGPT or many others, open source models, to perform automatic classifications of answers to open-ended questions. It's the same idea. Open-ended questions have, you can ask, like, you can obtain a very rich information from open-ended questions, but they are usually difficult to code if you have like a lot of information, more than 1,000 answers, and if you are in a small team. So you can use this type of tools to improve, optimize the coding process. The procedure is easy. Just first, identify a theoretical framework that contains definitions and categories then write an open-ended questions to ask about this the variable that you want to study, avoiding questions that can be answered with a yes or no, or with very short questions, or with very long, very short answers or very long answers. Okay, so if you can test them before collecting the data better, then you collect the data. And here, what I'm going to explain it using GPT or ChatGPT because it's the most famous one. But again, there are many other, many other models, open source models that you can use. So after collecting the data, you will need to create a prompt for GPT containing an instruction about the task. For instance, classify the following answers to an open-ended questions into the following categories. Then you add the definitions of the categories, an instruction about how you want to obtain the response. For example, just give me the number of the category. No? If you have 5 categories, just give me a 1, a 2, a 3, a 4, or a 5. And you can also give it some examples. So there's a limit in the length of the prompt. So just take into account not putting too many categories or definitions that are too long. Then here, it's really, really important, again, to calculate, to take a random percent of the sample and manually coding it between humans, no? Between me and another colleague, for example, and coding it with GPT automatically to see the agreement, to see if we can trust GPT when... Yes? Do you have a question or?
Thank you. Yeah, thank you very much, Samuel. I'm sorry. I think we have to end here your presentation.
No problem. No problem.
Fantastic, but we need room for the next speaker. It was very rich. We had many questions. I don't know if we have time.
If you have questions, if you don't have time, just ask them by through email. I will be pleased to answer them, or even arrange a meeting in Zoom or whatever if you want to know more about this. And again, I will give the slides to Pascal. So all this information, you will have it. If you want to know a bit more about this automatically coding process of open-ended questions, you can check it. It's the last 2 slides. Pascal, thank you very much for the invitation. I hope you a really good session, a really good colloque. Well, thank you for your attention.
Thank you very much.